Today's lecture is going to be on the divergence theorem. The divergence theorem is similar in spirit to Green's theorem or Stokes' theorem, except it's converting of a different type. Instead of converting between line integrals around a boundary and double integrals or surface integrals on the inside, the divergence theorem converts between integrals over 3D regions and integrals of on the surface on the outside of it. It relates surface integrals over the boundary of a three-dimensional region to triple integrals on the inside. So it's sometimes called Gauss's theorem. Gauss was pretty smart. He has a lot of theorems named after him, so we typically go with this name instead. The divergence theorem has the following statement. Let's suppose we've got a surface and it's the boundary of a three-dimensional region, and we've got a vector field that's defined on that three-dimensional region. Then the double integral of our vector field over the surface is the same as the triple integral of the divergence of f on the inside. And the divergence, remember, is grad dot f. So you might see it written that way instead. And this is provided that the flux is counted outward. When we're writing our surface, which is the boundary of a solid region on the inside, we want to make sure that our surface has the normal vectors oriented outwards, pointing out of the surface or pointing out of the solid region rather than pointing into it. Geometrically, what's this saying? The surface integral of f tells us, well, if we're interpreting our vector field as fluid flow, it tells us how quickly fluid is flowing outwards, out of this region in three-dimensional space. Whereas the triple integral of divergence measures rate of expansion. And so it tells us how quickly fluid is leaving that particular position. So what we're doing is we're adding up how much fluid is leaving all those positions on the inside. And these are the same. Morally, it's like the following. If we want to know how many people leave a house or a building, we could A, watch the exterior of the building and see how many people come out of each entrance and exit, or we could figure out how many people leave each individual room. If there are 10 rooms and one person leaves each room, then 10 people have left. We don't need to check the outside of the building at all. So that's basically the type of conversion that the divergence theorem is doing.